but I want to talk about geometry. So in parametric design, you can see one thing I didn't do is I could base dimensions on equations. So I could have taken that length of that part, and I could have told that my design parameters, my engineering intent is that the height of that part is half of the length of the part. So you can build equations into those parameters, and it lends itself really well to geometry. So now I've got an equation built into my design. But just simple geometry lessons. This is a real simple 2D print. I just want to find the length of this line, given all dimensions. So Pythagorean theorem here just to finish, to work through the line. But a little more complex geometry lessons. Ooh, now we can kind of see that. If you're asking your students to find the location of that point right there, it's kind of difficult. What we know in engineering, if I don't have this dimension or this point where that arc meets that line, if it's not dimensioned, it implies tangency. So that arc goes smoothly into that line. So right over here is how it actually construct that corner point. What the students actually have to do is project this line up, and I'll back up a step. In this lesson, what I've told the students is your design intent as an engineer is this is part of an overall slide, and these two walls, these two faces here, have to be parallel. So that's your design intent. No matter what else happens in this design, those two lines have to be parallel at this dimension. Now find that corner point. So what the students have to do is take a tangent off this circle, project that up parallel to this line, project that up, project a line perpendicular to this line to get that corner point. And a typical error here, a student would draw a line tangent to that, tangent to that. Well, as soon as they test if it's parallel or not, it's not, because this gets moved over anymore. So we start talking about design intent and start working with some geometry in the lessons. In another example of this, again, constructing information, they've got to find the center point of that arc up there. And they know the radius of the arc, and we know, I blocked it here in the graphic, but we know the dimension of the end point of that line. So we know exactly where that point is. We know where this line is. We don't know where that arc swings through there. And we cannot assume that that arc ends at a quadrant point right there. So what they have to do is create a construction circle based off that point with the radius given up there. And since we know, again, that implied tangency up there is a radius of 15, we know the center line of that arc coming through there is going to be 15 up. So that right there, if we swing an arc from the intersection of those two, we'll get a nice tangency arc down here that ends at the proper point of that line. That was a lot to talk through real quick. But geometry construction, right? And this is a lot of what we use CAD for. Now, this can definitely be done on paper. A little harder to create on paper. You don't have the accuracy built into the drawing, but you can definitely do construction methodology like this on paper. We did it for years, right? And that's what I started my career with, was on the more of the drafting tools.